Hi everyone, Tina here, and today I'd like to talk about comparing data sets. This is something you can be asked to do whether you're doing the Foundation or Higher GCSE course. The good news is there's a template you can use which will hopefully make it easier for you to access these marks. As we go through the template and the examples, I'll point out which parts are for the higher course only. So here's the template. It has two parts. One is for comparing the averages, and that might be the mean, mode, or median, depending on the question. And the other part is to compare the spread of data, and that might be the range or the interquartile range if you're doing higher. It's important to split your answer into these two parts to make sure that you get all the marks available. If we look at the averages one first, the template shows us that we're going to fill in the blanks. So for example, the mean for X is greater than the mean for Y. This means that on average, and then we're going to make a comment in the context of the question. If we have a look at the second part about the spread of data, again, we're going to fill in the blanks and make sure we're answering the question. I think this template will make a lot more sense with some examples, so let's have a look. Example 1, relevant for both Foundation and Higher. 20 students took a science test and a maths test. Both tests were marked out of 50. The table gives information about their results. And then we have a table showing the median and the range for the science results and the maths results. The question says, use this information to compare the science test results with the maths test results. Write down two comparisons. The fact that it asks us to write down two comparisons shows us that that two-part template is going to be really useful here. So the first part, remember, that was about comparing the averages. And in this case, the average given is the median. So let's use that. The median, let's say for science, is higher than for maths. You could do this the other way around. You could say the median for maths is lower than for science, up to you. But either way, let's make a comment in the context of the question. So this means that on average, students scored higher in science. Second comment about the spread of data. So it looks like the range for science is larger than for maths. This means that the data for science is more spread out or varied. Another way of thinking about this is less consistent. Now, the specific words you choose to use in that second part of the template are up to you, and it could depend on how you've been taught in school. Either way, as long as you're commenting on how spread out, varied, or consistent the data is, you will get the marks. Example 2, again relevant for both Foundation and Higher, and this time we're going to have to do some calculations before we can make our comparisons. So it says the table shows information about the heights in centimetres of a group of Year 9 girls, and we've got least height, median, and greatest height. Then we've got a stem and leaf diagram showing the information about the boys. Compare the distribution of the heights of the girls with the distribution of the heights of the boys. As I said, we're going to have to do some calculations before we can fill in the template. Reason is we've got things like the median for the girls, but we don't have that for the boys yet, so we can't compare them. And also we haven't actually got the range written out anywhere, so we're going to have to calculate that for both the boys and the girls. So if we start with the median, we know for the girls that was 165 centimetres. For the boys, let's calculate that from the stem and leaf diagram. Different people do this differently, but I prefer to use the method where you calculate the median position and then you work out where that is in the diagram. N plus 1 over 2, N being the number of data points. So there are 15. So we do 15 plus 1 over 2 is the 8th data point. Let's go ahead and find that in the stem and leaf diagram. 1, 2, 3, 4, 5, 6, 7, 8. That shows us that the median for the boys is 168 centimetres. We can now fill in our comparison for the averages. So we can say the median for girls is lower than for boys. This means that on average, the Year 9 girls are shorter. Now let's calculate our ranges. So for the girls, the least height was 150 and the greatest height was 170. So the difference between those is 20 centimetres. For the boys, we can get that data from the stem and leaf. So the greatest height was 182 centimetres and the least height was 158 centimetres. So range for boys is 182, take away 158, which is 24 centimetres. So now we can say that the range for girls is smaller than for boys. This means that the data for girls is less spread out or varied, or in other words, more consistent. Last example, and this one is relevant for the higher course only, says some students were asked how many times they each used their mobile phones last week. The box plots give information about the male students' answers and about the female students' answers. And then we're given our two box plots here. Then we're asked to compare the two distributions represented by the box plots. So before we can make any comparisons, we need to look at the data and maybe find, for example, the medians and let's say the interquartile range for this example. So if we start with the males, the box plot for them shows us that the median is 40. The lower quartile, so the first part of the box, is at 35. The upper quartile is at 66, meaning the interquartile range is the difference between them. So 66 take away 35 gives 31. If we do the same for the females, so just reading the data off the box plots, we get median is also 40. Lower quartile this time is 28. Upper quartile is 70. And therefore interquartile range is 42. Now we have our data, we can make our comparisons and fill in the template. So we can say the median for males, in this case, is actually the same as for females. And this can happen. It's not always going to be greater or smaller. In this context, this means that on average, males and females used their phone the same number of times. There is a difference in the interquartile ranges though, so we can say the interquartile range for females is higher than for males. This means that the data for females is more spread out or varied, in other words, less consistent. That's it for now. If you found this video useful, please do remember to like, comment and subscribe to my channel if you haven't already, and do share this with anyone else that you think might find it helpful. Thanks and see you next time.